of information in there, so we're going to focus on a couple of topics in particular. Before we begin, I do want to have a couple of thank yous. First of all, I'd like to thank Congressman Reed and Congressman Ryan and the House Manufacturing Caucus for allowing us to come in and make this presentation to you today. Second, I would like to thank some of our collaborators who received some financial assistance for this project from Grant Thornton. And so I know Ward Mel Hewitt is here with Grant Thornton, and we thank Grant Thornton for that. Also, we collaborated with the Manufacturers Alliance for Productivity and Innovation. They're a professional society of manufacturing executives that through networking and they learn better business practices and teach each other. They were very helpful in bringing us manufacturers to the table in October to have a facilitated discussion about smart manufacturing and information governance issues. I know there were one or two folks from MAPI here this year. Thank you, Chris. Thank you. And I'd like to thank also some of our advisory board members who have helped our manufacturing policy initiative within the O'Neill School of Public and Environmental Affairs at Indiana University. So let me begin, and I'll start with the project. And I'm Keith Belton, by the way. So I'm the director of the Manufacturing Policy Initiative at Indiana University. And let's get started. So the Manufacturing Policy Initiative is within the O'Neill School of Public and Environmental Affairs at Indiana University in Bloomington. Our aim is to focus on research, education, and outreach on the impact of public policy on manufacturing and manufacturing competitiveness. We are the only school of public policy in the country, as far as we know, with a specific initiative and focus on manufacturing policy, and we're proud of that. Indiana is actually the most concentrated state in the nation in terms of manufacturing, in terms of employment, and percentage of gross state product. And you can follow us on Twitter, and please do, and we're on our website. So this project we worked on was called Smart Factories, Issues of Information Governance. And our goal was really to explore information governance issues that impact smart manufacturing. The bottom line here is that a lot of attention gets paid to the technology of smart manufacturing and labor force issues of smart manufacturing, and legitimately so. But not enough issues are being not enough attention, in my mind, is being paid toward issues of information governance, without which you really can't have smart manufacturing. So a couple of definitions. So the definition that we're using for smart manufacturing is the integration of sensors and controls and software platforms to optimize performance not only at the production unit level or the factory level, but also the supply chain level. And there's the definition source the definition came from the Strategy for American Leadership in Advanced Manufacturing, which came out in October. The one thing I wanted to stress here is that when you have such integration, information is really crucial. And how you manage that information, how you regulate that information, norms of behavior for collecting, storing, and managing that information are really important and impact smart manufacturing. So, information governance are just that, norms of behavior for how we collect, manage, use, analyze, and put to use information, particularly information in digital form. And it covers lots of different topics. Here's a list of topics, not all of which are covered in our report, but they're all very important. Without technical standards, devices and sensors throughout the supply chain won't be able to communicate with each other, won't be able to talk to each other and generate information. Cybersecurity, as you might imagine, is pretty critical. Weaknesses and vulnerabilities in cybersecurity are really going to hinder investment in smart manufacturing. Personal privacy is a big information. A lot of the information that's collected in smart manufacturing might be personal nature or hit privacy issues. I think all 50 states have some sort of privacy regulation. In the United States and other countries are developing privacy regulations for how companies have to handle that information. Digital trade policy is a huge issue. As we try to move electrons across borders of countries, countries are taking different approaches to regulating and managing that information, and that impacts smart manufacturing. Artificial intelligence and machine learning in particular are going to be very powerful tools for managing the massive amounts of information that will be collected from smart manufacturing, and how we choose to regulate the norms of behavior or manage or use artificial intelligence are going to have an impact on smart manufacturing. And the industrial Internet of Things, if it reaches fruition, is going to require spectrum allocation. So there are all sorts of issues dealing with information governance that are really central to making smart manufacturing a reality. The promise of smart manufacturing is really mind-boggling. If you Google smart manufacturing and look for market reports, you will find incredible numbers about how much value will be provided and value added will be generated as we move towards smart manufacturing in this country and globally. You know, in the trillions of dollar range is not unheard of in some of these numbers. By 2025, hundreds of billions of dollars of value added within the next 5 years, et cetera, et cetera. This one report equated this kind of value to doubling of the operational profit for a typical original equipment manufacturer in the automobile supply chain. That's a lot, a big difference pretty quickly. But the one thing that I think a lot of these reports assume is that we're going to have optimal information governance in place that facilitates and makes all this happen. And I would argue that that's not necessarily so. So you can imagine suboptimal information governance. We don't have global standards in place that really allow and facilitate for supply chain integration, or we have critical vulnerabilities in cybersecurity that make manufacturers reluctant to link together with their suppliers or their customers. Countries might decide they want to impose a tax or a penalty or prohibit the movement of digital information outside a country's borders. We might have outdated regulation that for no other reason than it didn't occur to them that may preclude the use of artificial intelligence in certain situations. And we might have insufficient spectrum to accommodate consumer demand. So information governance is important. Another point that we think is really important to mention is that nations are making strategic decisions about information governance to benefit their own domestic manufacturing base. And this is not unusual. Germany with Industry 4.0, which is all about smart manufacturing, they've had a very strategic and heavily resourced effort underway for years. China, with Made in China 2025, is also moving toward smart manufacturing and making it a priority for the nation. And it's not unusual for nations to try to use policy to help the manufacturing sector. We certainly see that a lot with developing nations that want to industrialize and become and raise their economy and become a middle-income country or a higher-income country. But what's interesting to me is that even the leading manufacturing countries don't stop once they get there. They're always looking for ways to advantage their domestic manufacturing base if they can and take it to the next level. And I think what we're seeing in public policy across different nations, we're actually seeing some efforts to try to get there first and try to have a first mover advantage when it comes to smart manufacturing, and that impacts also information governance policy. So to look at this issue, we had an approach that we decided to have experts and academic experts develop white papers on some of these information governance issues, like cybersecurity, like digital trade, like technical standards, like cybersecurity and privacy. And we used those white papers and provided them to a group of manufacturing executives that were brought together by Mayhi in a facilitated discussion back in October. It was a very interesting meeting, and we delved into issues of information governance and questions about how manufacturers are investing and why and how they might change their investment strategies based on these issues. The Meridian Institute was our professional facilitator for that event, and I see Tim Neely here. Thank you for facilitating that. And we wrote that up along with the white papers in the report that we have provided to folks when they entered the room. And so I encourage you all to keep it, read it, and feel free to contact us with any questions or the authors with questions that you may have. What we want to do today and here's just a listing of the scholars that wrote the various papers. David Crandall, is an associate professor of informatics and computer science at Indiana University, and David, who's over there, will speak next. Scott Shackelford is in our School of Business at Indiana University and wrote a very extensive paper on cybersecurity and privacy issues. Susan Aronson with George Washington University. Susan is sitting back there, right? Yeah, wave your hand. Okay, there you go. Susan wrote the paper on digital trade and really fascinating for what's happening in the trade world and how countries are trying to address digital issues and create norms. And then Angus Lowe, who can't be here today, is a director of standards for Rockwell Automation, and he wrote a paper on technical standards. I think he's in Belgium. So for today's program, we have David and then Scott will speak. Our plan is that each one will speak for about 15 minutes, then take 5 minutes of Q&A, and then we'll move on to the next speaker, David first, then Scott. At some point, Congressman Tom Reed will join us. When he does, because his time is limited, we will stop the program and I will introduce the congressman. He will make remarks, and then we will get back to the program as I described. And we'll have room for questions at the end. It will probably go until about 1:15 or 1:30 for those who are keeping time. So I will start off with the conclusions of our report and our findings. First is that information governance will impact how and when companies invest in smart manufacturing. And all these findings really came out of that roundtable discussion when we had the 18 to 20 manufacturers responding and talking and having excellent discussion about these issues. The second finding is that collective action is needed to create information governance conducive to investment. And this collective action can occur through private sector action alone, such as voluntary consensus standards being developed, and or government intervention such as regulation or a combination. The U.S. approach to information governance differs in fundamental ways from the approach that other countries and regions of the world are taking, notably how China is approaching these issues, and how the EU is approaching these issues. When you look at the U.S. in particular, there does seem to be a lack of coordination among the various federal agencies and departments on these issues compared with the kind of coordination we see in these other regions of the world. And finding 4 is that when policymakers develop proposals to influence on these issues, they need to take the special features of manufacturers in mind in crafting policies. Sometimes we've seen policy proposals that are written without understanding the special needs that manufacturers have. So today's program, as I said, will go in the order shown on this particular slide. And I thank you very much. And with that, I will turn it over to David Sandel, who will talk about artificial intelligence. Thank you.
All right, thank you very much, Keith. So I'm David Crandall. I'm an associate professor in the School of Informatics, Computing, and Engineering at Indiana University. I am a computer scientist. I am not an expert in manufacturing. Keith asked me to come here today to talk a little bit about artificial intelligence, what are its strengths, what are its weaknesses, what are the opportunities, what are the challenges of it in general. So maybe cut through some of the hype of AI in general, and then talk about some of the applications to manufacturing in particular. So if you follow the headlines, you know that we've made amazing progress over the last few years in artificial intelligence. Things like facial recognition algorithms that can outperform humans, for example. These days on a variety of classic games that seem hard and seem to require intelligence, like the game of Go and chess and shogi and even video games and others, computers can defeat the human champions. I'll show you just a couple of examples of things that I think are neat. These are just sort of randomly chosen. This is some work at colleagues at Caltech and Cornell and elsewhere who have developed software that you can take a picture of an animal that you see in the wild and upload it to the site, and it will find the animal in the picture and it will identify the species of that animal among thousands of possibilities. So this is doing a task that I certainly cannot do. Right? I'm not a biologist. Let me show you another example. This is an example from my grad student's work He is working on automatic captioning algorithms that can sort of convert an image into a sentence that describes that image. So we can feed in a picture and it will say, I'm typing on my laptop computer, I'm shopping at a store, I'm eating a plate of food with a salad and sandwich. Okay, that's chicken teriyaki, but still, this is pretty good. I mean, 20 years ago, when I first started in this field, it was hard enough to get the computer to recognize like rectangles. And now we have some hope of being able to do things like this. And yet, at the same time, I think there's sort of storm clouds on the horizon because it's clear that in some cases AI isn't working as well as we think that it should, according to these other headlines. So things like autonomous vehicles that are failing to stop for pedestrians sometimes. So there was a paper recently that showed that face recognition is really accurate for middle-aged Caucasian men and not accurate, or not very accurate at all for African American women, for example. I love the case of the DC security robot that quit its job by drowning itself in a fountain because it didn't see the obvious fountain in front of it, just wandered right in. So let me show you maybe a couple of other examples. I showed this animal recognition example that I think is really impressive. Here's another example. This is what is this? It's a cat, right? The algorithm agrees with you. About 90% confidence a cat. Might be a tiger cat, might be an Egyptian cat, maybe not quite sure what kind of cat. Here's another image. What is this? The algorithm disagrees. 100% chance that's guacamole. Might be broccoli, might be a soup ladle, but the chance that it's a cat, according to it, is quite low. This is a little bit scary. Let me show you the second row of images from my grad student's work I was promoting before. Here's some other images. Let's see. A teddy bear is sitting next to a table, next to a tree in a car, a spoon and a big bowl of fruit sitting on a table with a laptop in the background, and my favorite. A man is holding a cat in his mouth. So this is sort of very mysterious, even to those of us who are working in the field. Why is it that AI technology can defeat probably any human who has ever lived in a game as complicated as Go and chess, but can make confusion as simple as this? So I'd like to kind of talk through this because I don't think it is very complicated once you kind of understand what is going on beneath the hood, even at a very high level. First of all, what is AI? AI is probably not building machines that think like humans because, you know, I have a brain that operates through chemical reactions and it's powered by the sandwich I just ate. It isn't powered by electricity and ones and zeros like a computer. So that's probably not what we want. Building machines that have human-level intelligence, I'm not sure what human-level intelligence is, so maybe that's not so great. I think maybe a definition would be to build systems that successfully perform tasks that seem to require human-level intelligence. But the way they do this is going to be quite different. The particular technique that is used these days most commonly for AI is called machine learning. Machine learning has a lot of hype about it, but really what it is about finding patterns in training data. So you give the algorithm a bunch of data, just like I would look at, I don't know, flashcards or something to learn a new language. Give the algorithm a lot of training data, and then ask it to find patterns. Ask it in particular to find mathematical models so that it can make new predictions in the future. These mathematical models are quite complicated. But underneath the hood, they're actually quite simple. We're just trying to fit mathematical models to data. The kind of state-of-the-art technique right now, at least, is called artificial neural networks. These sounds very futuristic, and maybe they are. It's taken us 50 years to get to this point. But really what they are just mathematical models that have some sort of intuitive connection to what might be going on in our brain. But they're just mathematical models. The state of the art these days, you'll hear the keyword deep learning, with deep neural networks. These are just neural network models that have a lot of parameters in them, a lot of degrees of freedom. So you need a supercomputer, or you need powerful computers to be able to fit them, a lot of data to be able to train them. That all seems complicated, but I again would like to argue that all of these successes and failures can actually be explained by a very simple concept. This concept that machine learning is just fitting models to data. So to do this, I want to go through a really simple example. Maybe go back to like your high school physics class, where you did experiments and you measured data, and then you tried to find patterns in the data. And I don't know, I made up an example here. Maybe we draw a bunch of circles, and we measure their radius and their circumference, and we plot them. And then, our physics teacher tells us, try to find the pattern. So it said, well, it looks like a line, so I'll draw a line. And then this line, this mathematical model, now lets me make predictions about future circles that I might encounter in the future. This is what machine learning is. It's just building these mathematical models to be able to predict things in the future. The trick is, well, there's actually two tricks. So one is that these models are immensely more complicated than just drawing a straight line, because instead of having two-dimensional data like I have here, we might have a million-dimensional data. It's really hard to imagine a million-dimensional graphs. The other thing is that the machine learning algorithm doesn't know what pattern it's looking for. So in this case, my teacher might have said, draw a best fit line. But if they hadn't, I could have drawn lots of other lines. I could have drawn that curve there on the right. I could have drawn that squiggly line down there on the bottom. And depending on which model I chose, I would have gotten the correct results on the things that I had seen so far, but completely incorrect results on data that I've never seen. And I think this is what explains some of the successes and failures right now with machine learning. When an algorithm sees a new example that's similar to something it's seen before, or where it's fit the model well, it can perform quite well. But if you venture outside of that, it can lead to surprising results. So for example, what is that? Doesn't really look like anything to me anyway, but according to the algorithm, it's a centipede. Because the algorithm has learned some pattern in data. It's learned, based on training data, what a centipede looks like, and this data point happens to fall within that same region, even though it's really hard to explain this intuitively based on human intuition. Here's a couple of other examples that I like. So that thing on the bottom left, it thinks it's remote control. You can maybe see why, right? The button's there. Or that thing on the top center that looks like the stitching of a baseball, it thinks is a baseball. So it's clearly, using some patterns, but they're not necessarily the same patterns that you or I would use. So I wanted to give a couple of takeaways about AI in general, and then I'll just talk for a couple of minutes about some of the implications that I think will happen in manufacturing where there is really great opportunities for AI. So the takeaways are that AI right now is basically about machine learning, more or less. And that is really a fancy way of saying fitting mathematical models to data. Computers are very good at finding patterns in data. They might not be the patterns you thought they were going to find, but they're very good at finding patterns in data. This means that AI and machine learning is typically only as good as the training data that you can give it. This means that for very rare events that you don't have very much training data for, like the mattress flying off the car in front of you as you're driving down the interstate, that's a pretty rare event. The system may never have seen that before, and what it does in that case could be quite unpredictable. That's because algorithms lack the kind of sophisticated intuition that you and I have that can deal with cases that we've never seen before. Make a best guess about what's true. Now, this is not to say AI is not useful. I think AI is actually about to revolutionize many parts of our lives. It's just we have to be careful about how we apply it. So I think AI is most successful, at least at the moment, when we have large amounts of high-quality training data available to show it, in situations where there's controlled and constrained environments. So something like a manufacturing floor is much more constrained than all the interstates of North America. So we can really make sure that the algorithm knows what to do in all the cases that it will see. It's successful when there's high tolerance to error. My cell phone tries to automatically organize the photos for me on the phone. It often makes mistakes, but it doesn't really matter. Nobody gets hurt if it miscategorizes a photo every once in a while. AI can be successful when there's collaborations with humans, when humans are in the loop, ready to take over if needed, or to provide a check on the algorithm to give that intuition when the algorithm doesn't know what to do. And in cases where fast, accurate processing is more important than intelligence. This is why computers are able to win at chess and Go, because they just have the raw processing power to try many more moves than I can think. So again, I said I was not an expert in manufacturing, and I'm not. I work in computer science, but I did want to tell you a couple of ways that I see manufacturing being used and likely will continue. AI will continue to be used in manufacturing sectors. AI has been used, computer vision has been used for a long time in quality inspection, and I think these systems will continue to get better and better, be able to spot defects at a rate and accuracy greater than what humans are able to do. I think virtual and augmented reality is a very big deal for training, for example, where you can look at a part, maybe new operator can look at a part and actually see, a 3D representation of what's behind that part, telling them what to do in order to align that part to existing pieces. Autonomous transportation is probably going to be huge. I don't know when it's going to come, but it's clearly on its way. In restricted settings like warehouse floors, it's already something that is becoming common, and soon we'll have probably smart cars and smart transportation, smart tractor trailers that will be at least partially autonomous, not fully. Some other examples of manufacturing. I think the idea of coupling AI with large numbers of sensors is very powerful. So you can imagine predictive maintenance kind of situations where in some complicated piece of machinery there are many sensors that are monitoring various parts of that equipment. They're reporting back to a central machine learning algorithm which has been learned to predict how long a device will last based on historical data. Again, this is a situation where if you have a lot of training data, this could be quite accurate. There are applications in generative design, which I actually find fascinating. So this is where one uses AI technology to actually evolve new designs. This example here is for a part that Airbus created, and instead of having humans single-handedly sort of design things and try things, sort of in a slow process, they instead built the simulated environment where they tested the parts in the simulator, but then the algorithm was actually recommending changes to improve that part over time. And so that algorithm, that feedback loop of simulation and generation and suggestion and so on, could be run much more quickly than it could be if it was actually being done by humans. I think we've seen robotics in manufacturing, of course, for decades, but collaborative robotics, where robots and humans can really work together, I think is going to be very powerful. Now this relies on the robotic systems to be able to sense what people are doing, what they intend to be done, and to interact with them in a safe and productive way. And then finally, this example of computers being able to outplay the champions in Go and chess. I think there are other kinds of strategy situations that we see where that sort of raw data processing power coupled with AI technology can really be used. An obvious one is supply chain management, for example. Maybe the computer does not have the raw intuition that people have, but it can sort of tabulate through huge amounts of data and recommend places where the supply chain efficiency can be improved. So that was the key messages. Those are the key messages that I wanted to relay to you today. If you're interested in any of our work, that's the URL for our website, and I'll just acknowledge the funding agencies that have sponsored all of our work over the years. Thank you very much.
So I think what we'll do is after each speaker, we'll take 5 minutes of Q&A, and we'll also have Q&A at the end. But if there are questions that folks have about AI and David's presentation, why don't you direct them to David now for a few minutes before we move on to our next topic.
How do you foresee quantum computing changing, interacting with AI?
Yeah, that is a great question. So I'll say, I've now said I'm not the expert in very many things. I'm not an expert in quantum computing. However, all of the work in AI right now in fitting these models and doing machine learning requires vast amounts of computational power. Quantum computing could really change the game because we know that there are limitations of current computing technology that we know, we can prove, we can never surpass. But if quantum computing comes, suddenly that changes the equation. Suddenly some of the calculations that may take us, days or weeks or months to do now could maybe be done in an instant. And that means that AI technology these machine learning algorithms could be run much more quickly. They could use vast amounts of more data. They could find better answers. It could really change everything. Yeah.
So it sounds to me as though the fundamental issue with AI in uncontrolled situations is that AI has currently no ability to absorb context, right? It does really well in games because games have rules, and so it knows what the limits of its potential actions are, and all it does essentially is optimize its actions within the rule set. That's why you can't identify a cat 100% of the time, because you don't even know that you're trying to look for an animal. So what, if anything, is on the horizon to try to make it possible for systems to interpret context correctly?
Yeah, that is a great point, and I think you are absolutely right that a lot of the problems that we see are because we are no longer dealing in closed worlds where we can control all of them. So there's something about context, right, but then we also, given the context, we can also use other information that we've seen in the past from common sense, from the laws of physics, all these sorts of things, to be able to make decisions that make sense given that context. There are many people that are working on this. That is a very difficult problem. It's been a problem for decades, so it's not something that will probably be solved immediately. Right now going on across Washington is a DARPA symposium on AI. I was there yesterday. They have several new projects that they're launching that are designed to see whether algorithms can learn the laws of physics, can learn common sense, can learn more of this contextual information that we need. It's a hard problem, but I agree with you that that's sort of the remaining barrier. Yeah.
Yeah, with all the hype of the AI that you mentioned, there's a lot of anxiety in the workforce that maybe machines are just about to take over from humans. But can you restate what I think I heard you say, if I understood you correctly, that it will still take a human to determine how to train the AI? Because you gave the example of the dots that you determine whether you're going to put a straight line or or a curve or what have you. So that is never going to go away because even in any application that you want to pick, somebody has to determine the strategy for training the AI. The AI does not have its own imagination. Can you confirm that, or who can do that?
Yeah.
Taking over the world.
That's a great question. I do not lose much sleep right now about AI taking over the world. I think it will fundamentally change parts of our society, parts of the workforce, and so on. I am not an expert in that either, so I can't really predict with any degree of confidence what will happen. I'm less worried about the technology itself and more worried about how we people will use that technology. Because I think right now, we're at sort of a crossroads of the way that we might use this technology. I really worry about using AI technology for, deciding who gets into graduate school or not, for example. I feel like that could be a danger because the system could learn biases that I don't want it to learn. It could use, I don't know what kind of criteria it would use, and I don't like that. I don't like that situation. It's going to have a profound effect, and that's why I'm really glad to be here to know that you folks are thinking about that, because I think we need to think about what the consequences are. But as for robots taking over anytime soon, I'm not worried about that specifically.
Well, if there's nobody else, I just did want to, you had the machine in the factory,
Right.
and then you had the truck on the road. To me, there's a big difference. The machine in the factory, that when you put that truck on the road, you're putting people who have no connection with that in danger.
Absolutely.
And I think that's a big thing that we ought to think very carefully about going down that road, in my view.
I completely agree. I think a lot of the challenges with autonomous transportation in the real world are not really about the technology, they're more about the humans. Because we need to make sure we're protecting human life. The machine needs to collaborate with humans, so not only does it have to drive safely, it has to predict what the crazy human drivers on the road are going to be doing also. I think that's a very difficult problem. Whereas you're absolutely right, within the confines of a shop floor, you can train the people, you can set up safety measures and so on. It becomes much harder in the real world.
Thank you.
Well, good afternoon, everyone. Now we get to the fun part, right? Cybersecurity. I know. As was mentioned, I am Scott Shackelford. I'm a professor at Indiana University where I chair our cybersecurity program, which we're excited about because it's a new partnership between our law, business, and computer science schools. So we're joining forces for the common good. So when the robots do take over, at least we can tackle them or something, right? We have a lot of different workforce development programs that we're running as part of this initiative, including a 3-week strategic studies program for the Army. Lots of digital badges, lots of certificates. So if anybody's interested in workforce issues, I'm happy to speak to that during Q&A or after. The other hat that I wear around IU is I direct a research program at the Ostrom Workshop. Has anybody heard of Eleanor Ostrom before, by chance? Couple have. She's famous for winning the Nobel Prize in Economics back in 2009, first woman to do so, but also for thinking through how we can get out of classic tragedies of the common situations by self-organizing, right? We're applying a lot of these insights now to some cutting-edge issues in tech, like blockchain governance, critical infrastructure protection, and Internet of Things governance, which is what brings me to here today, basically. This is a taste for some of the work that we have going on now. This program at the Ostrom Workshop has more than 70 affiliates all around the world, including Susan, I'm happy to say, Aronson from GW. A lot of interesting work going on. If you're interested, there's a listserv I can get you on, a lot of cool conferences coming up. This in particular project stemmed from that second book project you see up there on the Internet of Everything, which is a big survey looking at the security and privacy issues replete in this expanding universe of technology, right? How can we begin to scale privacy and security to match the threat potentially, as well as to take advantage of the opportunity? So this particular project, I think it started life, Keith, as a 1,000-word overview was my assignment. It wound up being 10,000 words, leave it to an academic, right? And still, we just barely scratched the surface. So what I'll do in my few minutes with you guys is hit a few highlights. There's more, obviously, in the paper itself, which is now forthcoming from the University of Michigan. But I'm happy to speak more broadly. We've done a variety of other work over the years, such as a much longer paper called Wind Toaster's Attack that I can point you to if you're interested as well. So just in brief, what I'll do is walk you through a few elements of the Internet of Things, its expansion, business potential, particularly in the manufacturing context. We'll focus in on a few major security and privacy issues. I'll talk through how we're approaching some of these on the U.S. side, identifying a few gaps, as I see them at least, along the way. As Keith mentioned at the beginning, we'll look abroad to see what lessons we might learn from the EU and other jurisdictions, and then wind up with kind of a broader discussion on how all this is playing into discussions of cybersecurity, due diligence, and norms, right? So that's kind of where we're headed. But we can take it however you'd like to from there. Okay, so we're constantly being screamed at these days about cyber attacks. You know it. There's whole studies on cyber fatigue at this point. I'm not trying to add to that, but it's not a new problem. Right? Cyber attacks have been around for decades at this point. Just a few months ago, we celebrated the infamous anniversary of the 30 years since one of the world's first documented cyber attacks, the Morris worm. Right? This was launched by a grad student at Cornell named Roger Morris, infected MIT's network, led to one of the first DDoS attacks. Roger was prosecuted under the then pretty recent Computer Fraud and Abuse Act, but that's despite the fact that he sent notes of apology to everybody who was affected by that. Wouldn't that be nice if cyber attackers still did that? Come on, where's the civility? But don't feel too sorry for Roger. He's now a professor at MIT and a dot-com millionaire. So things didn't work out too poorly for the world's first cyber attacker. What's different now, of course, is how quickly these attacks are proliferating in numbers, sophistication, and severity, and the fact that they're targeting companies and countries alike, right? Now, we don't have a lot of good hard data to go on how much these attacks are costing, how many are even happening, and how they break down by type, right? We know that since 2011, the Securities and Exchange Commission has been suggesting that publicly traded companies disclose these data. A lot either aren't aware or simply aren't just not doing it. There is some positive movement with GDPR that I'll talk about, so hopefully we'll get some more data, but so far we're left to rely on secondary sources, and they paint a pretty bleak picture, which has left plenty of practitioners like Jim Lewis at the Center for Strategic International Studies to say things like, right now we have a faith-based approach to cybersecurity, and that we pray every night nothing bad will happen. Right? So hopefully we can do better. But the problem is only getting more acute because of this expanding Internet of Everything. Now pick your stat, right? I've seen a huge range. Something between 20 and 50 billion devices are supposed to be connected to the public internet by next year. The same year that we'll have 6.1 billion smartphone users around the world and 250 million cars connected to the internet, right? Which is just a huge, huge number. And it's only going to proliferate from there, as you see. Now there's a huge business potential here. McKinsey has estimated that this network of things could contribute as much as $6.2 trillion to the global economy by 2025. And as Keith mentioned at the beginning, 1.5 is going to be directly, at least, in the manufacturing context. But there's also enormous risks to consider. At the Black Hat Cybersecurity Conference recently, there was a survey that went out, and 93% of the respondents there saw the future of IoT not necessarily as something smarter, but as something more dangerous. And they've predicted that nation states in particular will target or exploit these connected devices in coming years. Right? And we're already seeing some evidence of that with North Korea and WannaCry, Iran, of course, and Saudi Aramco, the Mirai botnet, the list goes on. The FBI has put out various warnings, including in the manufacturing, utility, and healthcare contexts, and dozens of governments around the world, including ours, are trying to decide what the heck we do about it, right? Some are more bleak than others in terms of how they're viewing this. For example, Bruce Schneier, who recently wrote this great book, Click Here to Kill Everybody, he quipped that, we're beyond the point, he thinks, that we need to discuss regulation versus no regulation for connected things. He thinks we need to discuss smart regulation versus stupid regulation. So the natural question is what we're doing now smart or not, right? Particularly in the industrial Internet of Things context. And that's getting more acute, I should say, because just a few years ago, for only the second time in history, we saw a cyber attack cause physical damage, right? So this was at a steel mill in Germany, and the blast furnace overheated. Attackers got in from its business network, right? And there have been unconfirmed reports of other similar incidents, including at a petrochemical facility that was compromised via a coffee maker. So I just like to zoom in on the coffee maker in the corner now. So what are we doing? Are we getting a handle on this? At the Ocean Workshop, we do a lot of work on what's called polycentric governance, which is on how you get all these different stakeholders at various levels to work together to address a common problem. Right? So when you look at this list, you see a lot of federal, you see a lot of state initiatives that I'll tell you more about, a lot of civil society work, such as from Consumer Reports and Public Knowledge. There's a lot going on that's surveyed in the paper, but there's a lot of gaps still, too, right? So the Federal Trade Commission, for example, has done some great work on putting out this guide for business, this top 10 guide. A lot of manufacturers have utilized this in various ways. It's been very helpful in establishing something of a baseline, along with NIST and their cybersecurity framework, of course the new privacy framework, the pending IoT framework. These are also incredibly helpful tools, but they're only just the beginning, of course. At the state level, there's a heck of a lot going on, right? Now we're aware of California and all the things happening there, of course. As of next year, not only will the new privacy law be coming into force, but we're also going to have the new IoT law. So as of January next year, any manufacturer of a device that connects directly or indirectly to the internet, and as a place of business in California, must equip that device with reasonable security features designed to prevent unauthorized access, modification, or information disclosure. Right? That's January next year. That mirrors a little bit, I should say, what we saw in the IoT Cybersecurity Act of 2017 that some of you guys might be familiar with. This would have called upon the government to do 4 things in contracting: ensure that devices are patchable, that they don't contain known vulnerabilities, that they rely on standard protocols, speaking to the communications piece, and they don't contain hard-coded passwords, right? So you can kind of see California's effort here as a step in that direction. But they're not alone. As you see up there, in some areas we see a heck of a lot of convergence. We have 50 versions of these data breach notification laws at this point, as you're aware, right? Surprisingly, I think at least, there's a lot less when it comes to anti-DDoS legislation at the state level, as well as anti-ransomware, which is kind of surprising given the waves that we've seen of NotPetya and all that over the last few years, right? So in other words, I think a lot more needs to be done, but we also need to learn from what some states are doing here, right, as we look to see what role the federal government should play. Another important source of information is, of course, what's happening in the EU and otherwise. The General Data Protection Regulation has been enforced since last summer. I know you're aware, many of you of that already. It has a lot of different facets to it. We won't be able to do justice. If any of you are going on spring break soon, I encourage you to take that 88-page document to the beach. It's a great read. But in brief, these are some of the key highlights. As relevant to manufacturing in particular, there's a lot in there on postmortems after cyber attacks, on mandatory reporting of 72 hours after a data breach has occurred. Data portability is going to be really important for manufacturers in particular, as is certifications, which I'll say more about in just a moment. But first, I'd like to welcome the Congressman. Thank you so much. Yeah.
And I just wanted to say thank you again to Congressman Tom Reed for helping us tour of this room and giving us an opportunity to talk about smart manufacturing and why policy is important. The congressman is representing New York's 23rd
That's correct.
district since 2010.
Correct.
Youngest of 12.
We're not quite.
All-American swimmer.
Down the floor.
Yeah. Attorney, mayor, and still lives in where he grew up, right? So Corning, New York, with home of a company of the same name, with a great innovation record and history in America. So let's welcome Tom Griever.
Well, thank you, Keith, and it's great to be here with you. I just came by for the free lunch, Dave. They told me, but no, I'm just kidding. No, it's great to be here with you. U.S. manufacturing is something, when I came into Congress in 2010, that is near and dear to my heart. Coming from Corning, with a rich legacy of innovation, R&D, research and development, and really putting out products that have changed the landscape of America's history. I mean, we're talking the light bulb back in Thomas Edison. We're talking about, Pyrex and Corningware, changing kitchenware across the world. Everywhere I go, everybody knows what Corningware is. We don't even make it anymore. World Kitchen bought it, now it does it. But I was with Bibi Netanyahu for Pete's sakes, and he brought up Becky Corningware, and that was breaking the ice moment with me. But anyway, and then you got fiber optics, glass and everything else, and the way they're manufacturing. So, but it's not just Corning. It's across all of America. And we are seeing the rebirth of U.S. manufacturing. Today I spent over an hour with the trade ambassador, Bob Lighthizer. I've been in the committee numerous times over the last few months, and been with the steel folks. So we have Nucor in the district, and I would just tell you, what I sense is what we envisioned when we got here in 2010, is that U.S. manufacturing is coming back. It's not going to be the manufacturing, that as we go to high schools and talk to the kids that are going into the potential programs, and sometimes I get a pushback, well, that's really not the career we want our kids to be exploring. I've had literally guidance counselors tell me that, and I get so frustrated, because, they're thinking of the 1920s, the 1800 type of manufacturing, dirty, dangerous, and that type of stuff. But all of you know what I know, and that is U.S. manufacturing is nowhere near that. We are talking safe, clean, innovative, high skills, computer-based, science, engineering, mathematics, the whole 9 yards that is igniting a whole new level of exciting manufacturing opportunities. And, I was with Ben Carson not too long ago, and he was talking about, how he was going to see a company that was manufacturing homes by 3D printing them into the housing market. I mean, that's just crazy, kind of like Star Trek type stuff. So anyway, I won't bore you with my passion, but it is a passion I carry, and I will just tell you, what you guys do here in manufacturing is important. And we appreciate the data analysis today. I appreciate the smart manufacturing that we're continuing to promote. And most importantly, I want to thank my co-chair, Tim Ryan, who truly is also a leader in regards to U.S. manufacturing. He and I have developed a friendship and a passion on this issue, and working with him is something we're very proud of, and we appreciate him and his team working with our team to put these together. So keep up the great work. Our door is always open to you, and as we have U.S. manufacturing going places that we only see getting higher and higher going forward, we will be in your corner as we go on this journey. So thank you very much.
Thank you.
Thanks, please. Thanks, guys.
Excellent, thank you so much. And certifications. So there's a lot of interesting work kind of going on in the EU right now on this. The UK actually has something called the Cyber Essentials Plus certificate, where companies can actually apply to the government and have a best-in-class cybersecurity label kind of slapped on their particular product or service. We haven't gone that far. Obviously in the US, Consumer Reports is doing a lot of interesting work on the digital standard. We did a project with them this last winter. A lot of cool stuff going on there. But that's just one end of the spectrum. Other governments like France, for what it's worth, are considering mandating liability for security lapses on the part of IoT manufacturers right now. So for U.S. companies, looking abroad, looking to expand to some of these markets, it's important to take note of some of those developments there. Here's a shot. China's approach is pretty different. Much more state-centric, of course. All this is classified as critical infrastructure, but right off the bat, has a very different regulatory standpoint. What we try to do in this particular work and in some related efforts is dig into some of the leading manufacturers around the world, including US, Germany, and China, to try to show where these countries diverge in terms of their manufacturing policy and thinking about cybersecurity due diligence, but also to show where some of those commonalities are. And as this chart shows, there's some common ground we can work from, especially as we think through standards that could help effectuate the expansion of some of these industries. So when you're looking around the world, IoT governance is, you can kind of picture it as a bit of a spectrum. There's dozens of countries that prefer this much more bottoms-up approach, a much more voluntary approach to this problem. NIST alone is cooperating with more than 25, right? So that's important to keep in mind. Obviously, the other end of the spectrum, that's a very different approach. And for global manufacturers, it's important to keep the upsides and downsides of that in mind. All this is feeding into discussions about the role of international law, including protecting civilian critical infrastructure, like factories, right, from cyber attacks. That's been part of the G7, the G20, the UN Group of Government Experts list for some time now, but the critical piece is enforcement, right, is enforcing those norms after they are created. That's why I'm so thankful for the work that the Cyber Peace Institute and some others are doing right now. So the last section of the paper is what the heck do we do about all this? This is a bit of a laundry list of ideas. Obviously, there's a lot more the Federal Trade Commission could do with some more resources, some more guidelines there. Same with the SEC. NIST is already doing some great things. They could do even more. There is an important role here for civil society and other ones as well, of course. We've done a little bit of work over the years, too, on looking at analogies, including sustainable development. All right? So what can we learn from the green movement as we think more broadly about risk management and apply it to cybersecurity? Some of those certification ideas that we mentioned a few minutes ago, that's part of it. All right? Absolutely, kind of labeling. Also, integrated reporting, the sustainability reporting can help, too. One quick example of a manufacturer, Eli Lilly in Indianapolis, is now including information on medical devices that they put out in their integrated sustainability reports, particularly their data privacy and cybersecurity efforts for those devices, right? So we're starting to see a little bit of the sustainability and cybersecurity worlds combining here in some interesting ways. Of course, blockchain is the answer, right? Regardless of the question, blockchain is the answer. But we do offer a little bit of input on that, particularly on the supply chain element that David so aptly talked about before, and we can get more into that if folks are curious too. And cyber risk insurance, particularly for small manufacturers, that can be a godsend, right? Though, of course, you have to think also about the flip side, the moral hazard argument. So maybe these companies are going to think they're covered and not put into place the proactive cybersecurity best practices that are essential to safeguard their facilities and safeguard their customers. So, at the end of the day, what we're pushing for is a vision of a more stable cyberspace, right? There's a lot of ways to get there. This, believe it or not, I did some tooling around. This came from the Vatican a few years ago on a definition of cyber peace, all right? Looked even better in the original Latin. For what it's worth, we tried to simplify it a little bit. The goal, it can't be the end of cyber attacks. That would be great. We'd all love to get there, but it's just not going to happen. This is an exercise in risk mitigation, just like in the sustainability context, right? But we think we can make a lot more progress by taking a network and distributed approach to this network and distributed problem, right? So, a few ideas. Thank you so much again for this wonderful opportunity. I welcome some questions now. I understand we have a few more minutes after that, too, that we can both take some follow-up questions. Yes.
Quick comment and a question.
Yes.
The comment is you're off about 20 years for your history on the first malware attack.
Oh, you tell me.
Having been
68.
a victim of it, it was the infamous Cookie Monster.
The Cookie Monster.
And that was back when it was civil, and all you had to do is it grabbed your machine. We were using terminals and mainframes at the time. It grabbed your machine, a picture of the Cookie Monster came up, and froze your program until you typed in cookie and gave it a cookie, and then it released your program. And that's now 50 years ago.
Wow. Okay,
I just throw that out
Yeah.
how long it's really been. My question is on the policy towards cyber. There's maybe can you talk us through the difference in policy necessary between cyber espionage, data breaches, and cyber sabotage? Especially, for example, on the resilience and the restoration. There are best practices for after attack in data breaches, what to do. That's very different than if you've got a meltdown in a steel factory. So can you talk about the differences, and can we use the same policy for both of those?
No, it's a great question, yeah, because we didn't even really have a chance to get into some problems that you're alluding to there, right? Like, we're on the espionage side, insider threats. So a lot of this is how do we keep, external bad actors from doing things like overheating a blast furnace or stealing our trade secrets. But for problems like economic espionage, that's really difficult. You have to get human resources and your IT folks on the same page, and that's not easy to do. So the policies to defend against external actors that are trying to, do sabotage, that's a lot of defense in depth, right? Some sectors are further ahead than others in that, obviously. FERC, a good example in the electricity context. Healthcare, finance, sure. But when you look across the board, there's a lot of different manufacturing contexts where there's just not as much guidance. So on the defense in depth side, I think more could be done, and maybe NIST could play a role in that, absolutely. On the espionage side, this is a really dicey problem because of that problem of insider threats, because of the difficulties of getting all of these law enforcement actions only here in the U.S., to say nothing of around the world, to work together. The short answer is there's not a one-size-fits-all policy to deal with all aspects of this really multifaceted problem. I think when it comes to economic espionage in particular, we have to do an all-the-above approach, right? So that can come everything from industry groups and civil society, putting out different lists of best practices. This has been done, which is great. FTC getting involved, which is wonderful. All the way up to trade agreements, including trade secrets protections, and for example, bilateral investment treaties that can help. So I'm a fan of just throwing everything at the wall and seeing what sticks, because it's such a monstrous problem. Other questions? Yes, please, sir. Yeah.
Where do you see the role of AI in cybersecurity?
Yeah. Well, both on the offensive and defensive side, and David might have some thoughts on this as well. But clearly, on the defensive side, this can be really powerful because, as David was mentioning, right, if you have a lot of information that you can bring together and chew through, you can actually do some predictive analytics. You'll actually know something about when you might be attacked, and maybe even the type, the duration. You'll have some background going in, and that can help you be more proactive, because it's just way too common to have a very reactive mindset when it comes to this. But of course, also on the offensive side, this is a really powerful tool, right? Because you can troll around. There's websites, for example, called Shodan. Some of you might have heard of. This is like a search engine for the Internet of Things, right? Which is a great tool for defenders, but also a great tool for attackers. So if you utilize those types of databases, then you can quickly see where the vulnerabilities are and exploit them. But I'm not sure, David, if you had anything else you wanted to offer on that, or we can come back to it later during the more general Q&A too. But that's a great question. Yeah.
Thank you.
Oh, please, sir. Yeah.
Is China requiring for their cyber security, are they requiring the use of their own standards and their own equipment? And does that lead you to believe that we may be heading for a two-sphere world in cybersecurity?
Increasingly, yeah. So it's no secret that China's been much more active, and when it comes to creating technical standards, not only 5G, but even in organizations that have historically been really grassroots, like the Internet Engineering Task Force, IETF, right, which goes through lots of these protocols. If you push it to an extreme, we've done some work on the new digital divide, right, and what this world that we're going into could look like. It's not going to be as simple as an Eastern and a Western Internet, but there is going to be more fragmentation, I think it's fair to say. How that plays out for business is not ideal, especially for businesses that want to go global. So that's going to have an impact on the types of markets they can utilize, but also when it comes to just us as users and human rights. I mean, this is really going to have a lot of implications. So I'm not in the camp that I think we're screaming toward full internet balkanization anytime soon, but I think there are some worrying signs that we're headed in a much more kind of bifurcated direction, and absolutely that has an impact on global manufacturing, including on us. Cool. Any other? Okay.
All right. Well, thanks, Scott.
Thanks so much.
So you've heard from two of the authors of the white papers of the four that we had commissioned for our roundtable speak, essentially going over what you'll see in the document. We also,
No, I just put that so that it was.
my next slide. How do I access my next slide? So yeah, there's one more.
This is the right one, right?
Well, this is that the end of the, shouldn't be. That works.
Like that one?
Yeah.
Sorry, I think for you.
Table discussion, to look at these various issues like cyber and like AI, and ask CIOs and CTOs of these firms how they're investing in smart manufacturing, how do these issues impact where they're going on smart manufacturing. So this lists the manufacturers that are sitting around the table. What I liked about working with MAPI is that it's not an advocacy organization, so these companies didn't come in with a unified position on any of these issues. They were coming in as experts and technical experts. Most of them tended to be CIOs or CTOs. The range of companies, their annual revenues are between 1 billion and basically 15 billion. That means they aren't really small, but they are global. They have to worry about what different countries are doing. And these people have been tasked with trying to move their company toward smart manufacturing. And they also aren't the biggest companies that have so much resources that they can tackle these issues so easily, more easily. So I'm just going to briefly go through the summary on each topic and what the takeaways were from that roundtable discussion. This obviously isn't a representative sample of what all manufacturers have said, but we thought by getting a smaller group of folks to come together and have an in-depth discussion, we could get more depth and knowledge out of them. First of all, about AI, they all kind of agreed they have great difficulty attracting talent of AI into manufacturing. The skills gap is a big thing to all manufacturers right now. It's especially true with respect to smart manufacturing and skills in AI. They see people coming out of Indiana University and others wanting to work for Google and Facebook and not necessarily wanting to go into the manufacturing sphere. And yet they need that expertise to take the manufacturing data and do something with it. There was also a question about the lack of auditability of AI. If AI does something wrong, do you ever know why it did something wrong? And there was great trepidation about letting AI just make decisions on the factory floor without human overseer. You know, if you have downtime on a factory, you want to be working at capacity, you want to be working 24/7. If AI, an algorithm suddenly shuts things down or a machine breaks, that's a big, big problem. So they really emphasized actionable intelligence from AI and the need for human oversight when they're applying that technology. On technical standards, they said that it's challenging with technical standards because technology is changing so rapidly, and it takes a long time to set a standard, right? I mean, the concrete block, the 8-inch by 16-inch concrete block, took 12 years to develop that standard for that concrete block, right? And you notice how technology is changing in the smart manufacturing world with these digital sensors, et cetera. So this poses a real challenge for your company. You're trying to invest in smart manufacturing. You'd love there to be standards that you can invest in, but if you wait too long, you could miss the boat competitively. And then you're in a situation where you have to bet on beta versus VHS, and you don't know which one's going to win in the end, right? So there was a lot of discussion about that. They certainly made the point that governments in other countries are being more aggressive and being on standard-setting bodies for a lot of these standards that are going to be emerging. And there are hundreds, if not thousands, of technical standards that kind of reflect what's needed for smart manufacturing. NIST issued a report a couple of years ago on standards, technical standards for smart manufacturing. That's a great resource and overview about what's going on in that realm. And they also talked a lot about SMEs and trying to get small and medium manufacturers involved in some of these standard-setting activities, both in their development and in their adoption. On cybersecurity, they made the point that cybersecurity for IT is very different than for operations technology, the kind that controls the factory floor, and the priorities are different. And solutions to cybersecurity for IT can be very different for OT, and legislation that's written or proposed to try to solve the cybersecurity problem needs to be cognizant of these differences and what manufacturers face. They talked a lot about how smaller companies lag larger companies, and this is a problem if you want to link supply chains. You're only smart manufacturing, you're only as good as your weakest link on cybersecurity. This is a real challenge for integrating outside of the factory and upstream and downstream of customers. And one company made a very interesting point comparing the NIST framework for cybersecurity and the lack of a federal privacy framework in the U.S. And when we had this roundtable in October, companies were still trying to comply and get up to speed with the EU GDPR law, right? And one company said, why shouldn't I just take the EU law and make that my company standard globally? Right? And that kind of comes down to the question that as companies set laws and requirements, they may be setting a global standard that all companies that operate globally are going to need, because companies are looking for one standard for all their factories, not different standards in different countries. And so countries that are leading in privacy and regions like the EU can have a disproportionate impact on where global manufacturing is going. And then finally on digital trade, I think they all realize that here's an area where governments are really going to have to set the rules. This isn't going to be some bottom-up kind of approach. When we have norms for digital data, and as they evolve, as trade agreements come about, we're going to have more and more of these issues with respect to electrons crossing national borders or information being able to leave the country or not, right? So in China, if you collect Chinese information on Chinese consumers, you have to ask government permission if you want to send that information outside of the country, right? You have data localization requirements where you have to keep your data in the country in many cases. And that's very different from, say, the U.S. approach and the U.S. preference with respect to digital trade, where the U.S. government approach is free flow of electrons across borders. Government shouldn't have access to algorithms. There shouldn't be any penalties for companies that want to move and shift data around. The USMCA agreement is a very interesting read with respect to these issues. It certainly reflects the U.S. approach to digital trade, and it also shows a line in the sand that's being drawn against the approach that we see in China, and perhaps more subtly, a different approach than what we see in the EU on issues like privacy. So looking at trade agreements and as they evolve, we can see these norms developing that are going to affect global companies. And we definitely see a difference between what we see, say, in China and the EU and the US on a lot of these information governance issues when it comes to trade agreements. And then finally, just an observation after listening to these folks for a night and a day and talking, and that is, manufacturers tend to be pretty conservative investors. They, if they're going to spend a lot of money, they want to be very careful and very sure. And so they kind of, in a lot of ways, these people are saying on smart manufacturing, we have to make a big bet, because smart manufacturing is the future. They all realize that. They all know they have to move their company there to compete, to survive, to thrive. But at the same token, without knowing what the norms and the rules are for information governance, it's a real challenge on how they do that. And that doesn't solve the problem. It doesn't give you a policy solution to anything. But I think what we wanted to take away here is that, that there are information governance matters, right? And so we have to consider that as well as technology, as well as workforce issues when we're trying to move the nation towards smart manufacturing. A couple of other points that, right, 115. I'm going to skip this approach, but this very quickly was just kind of to show the difference between the U.S. approach toward these information governance and smart manufacturing issues, which we defined as market-driven, and a preference for private sector leadership. China, which is a very managed approach, top-down performance standards, policies and practices to ensure Chinese firms become global leaders. We also compared in Germany and the /EU. Germany often drives EU policy, and Germany is quite the successful manufacturing company. Germany has a very coordinated approach where the government and industry work very, very closely together, a significant input from all stakeholders, from labor, from academia, etc. And we see that in various examples as well. I do want to say that we also see U.S. efforts to lead in governance. Here are examples where we think the U.S. is trying to show leadership and very positive developments in terms of these governance issues. But we also think, let's This is less so the roundtable folks and more me, right? And some of my colleagues when we're writing papers also about differences between how these different countries are approaching governance issues, right? So we definitely see the U.S. could improve in terms of interagency coordination and leadership on these information governance issues. We think the government's power as a purchaser of manufactured goods could be leveraged to greater avail to try to move industry towards smart manufacturing, and that the Manufacturing USA program is a good thing. It does get, some of the institutes are getting into issues of governance, and that information governance role ought to be expanded. So the takeaway messages for the whole project really were what was shown also, I think, in the beginning. That smart manufacturing is the future of U.S. manufacturing. Information governance is actually really critical to enable smart manufacturing. And the country that sets global norms for information governance will give its domestic manufacturers a competitive advantage. Thank you, and I think what we'd like to do is take Q&A overall for folks. Yep.
So my question has to do with, I think, kind of everything, all the topics you guys have spoken about. But one of the issues that you spoke about was we don't really know how AI comes to some of the systems. And I know David had spoken in another setting about how difficult it is to figure out how you give a certain set of problems to an AI and how they come to a solution. And I'll give you a brief example of why this bothers me, what I want to know we as policymakers can do to protect manufacturers. So, you give two kids the same calculator, the Texas Instruments calculator, you teach them how to do it, you give both of them the same formula, they get the same answer. The answer to that formula isn't necessarily owned by Texas Instruments, that's just a tool that gets used to it. But then when you bring in AI into the field of design and the field of manufacturing, and the example that you gave is, some aerospace industry says, we have this problem with this part on our airplane, and AI kind of comes to the final appropriate design solution at the end. First of all, does that, end solution belong to Boeing if Boeing used, Lockheed's AI to come up with that? And secondarily to that, when you're talking about, theft of IP and manufacturers stealing something from other manufacturers, be it, by hacking and whatnot, how do you prove that, okay, this manufacturer developed this design on their own or developed this design with an AI, but they got to that solution because of this manufacturer, versus another manufacturer that may be using the same AI and happen to come to the exact same solution because they're using the same AI. Does the first manufacturer own that piece now? Does the second manufacturer own that piece? And secondly, how can you even prove that the other one stole it if you can't look into the AI and say, well, these people designed it with their AI. How do you prove that you didn't design it with your AI? You're just saying you did, and that's what popped out.
Well, that's a very simple question. A very complicated question. David, do you want to take a crack at that? Notice how I segued, right? Very.
I don't know one's algorithm. Yeah, I don't have any brilliant thoughts on that. I assume there must be precedent for some point in the past where we were also facing some technology change. I mean, I can't think of a specific example, but when the printing press came and it changed everything in terms of who could really be writing and so on. I mean, there must be some kind of historical situations that we can look at for some guidance of that, but I don't have any sort of brilliant thoughts about how to do this. And then, of course, there's also the issue of liability, right? If my self-driving car has an accident, is that my fault? Is it the software developer's fault? Is it the car manufacturer's fault? I'm not sure. I don't know.
And is this going to require policymakers to consider this issue? Are we going to say that the outcomes of AI are designed, they're proprietary to the manufacturers using the AI? Or is someone going to be able to say, well, this involves no additional human input, so really this should be accredited to Boeing and the creator of the AI. And I'm just bringing this up because this is how policymakers often think, is what can we be doing to make sure that these disputes that ultimately will come up between manufacturers are able to be resolved, and is going to require a complete overhaul of how we even think about IP. If machine learning uses an infinite number of variables and examples across the world, what prevents someone from saying, well, you came up with this dress design because the AI used a picture of a dress that I used. So it's just something that I think we ought to be thinking about.
Yeah, That's fascinating.
Before the next question, I just want to say for folks who have to leave or have other, or need to leave when we're still taking questions, feel free to take food with you on your way out if you would like. And also, if you did not RSVP, if you could leave your name and contact info so we can send you additional info and slides and give you information afterwards, that would be helpful. But other questions? Yes, sir, in the back.
All of the smart manufacturing policy issues that you're talking about in your presentations seems to be at the federal level, whether it's US, China, or whatever it is. At the state level, aside from right to work or tax incentives, and are there some states addressing issues like this better than others, or to attract more manufacturing through other policy issues which are aside, different than those two that I mentioned?
Yeah. And I think it's certainly, and we didn't look at that, right? But I think you're certainly right that states have their own approaches to a lot of these issues, and states could be strategically changing the laws to try to get to encourage certain kind of direction in manufacturing at the state level. So I think I wouldn't be shocked at all if that's happening, and I'm going to look into it some more because I think it's a fascinating question.
With respect to point number 2 on your last slide, it seems to me that I wonder how much DOD and government actually move the needle in terms of their consumption of manufactured goods versus total U.S. production or worse, total global production. Does the government, absent its power to make laws, okay, just as a consumer, does the government actually have the push, from an economic standpoint, to make a difference?
Yeah. And I think the answer is the military defense supply chain is not an insignificant part of the manufacturing economic GDP, for example, of the country, but it's also a very influential one, right? So I think it's not so much if you get the industrial defense supply chain to change, you're changing all of manufacturing, but it sets a precedent and practices and standards and pushes them forward that other manufacturers can learn from.
I think that would be an interesting subject for some follow-on research.
Absolutely.
To find out whether or not the other stakeholders in the problem actually agree that that's the case.
Right. And I think it's also challenging, even if you agree it is the case, doing it is quite another problem.
Oh yeah, then you have.
I mean, the DFAR, the Federal Acquisition Regulations for defense are, quite voluminous and intricate. And I would suspect that there would have to be quite an effort to try to find a way to do what this is suggesting, given the current way the process works. So there's just.
Yeah, if you can advance the slide to the next one. There was a list of stakeholders somewhere.
Oh, you mean the
right
folks?
Yeah, right here.
Okay.
This is the one.
You mean the list of the people at the round table?
That's okay. No, that's fine. That's fine. I would add to this list the Industrial Internet Consortium. It's a private sector-driven group of companies, research institutes. There's, I think, one government entity from all over the world, from China, from India, from Germany, most from the United States. Very small, medium-sized, and large. And among other things, they do deal with governance issues. I think about a year or 2 years ago, they issued a white paper on standardization, how to go about setting standards in that area of industrial unit. And from what I know, they are extremely cautious, and I think you're absolutely right, that the US and the IIC is taking a very pragmatic, market-based approach to standardization. Let's see what works. Let's push it over to the standards institutes, NIST and the others, and let them sort it out. Versus the Germans, they use 4.0. When I talk to them, they are unabashedly pushing for standardization. Their mandate is to have very small, medium-sized companies. And the sooner you set up the standard, the sooner you can replicate any kind of intellectual property, push it up the value stream, and empower everyone. So I think, from my perspective, I think it makes sense to be a little bit cautious and let the marketplace determine where the innovation is going before setting the standards. But But IIC should be right up there within this list because in industrial internet, which is another word for smart factory, I think we are right up front there.
Excellent, excellent. Other comments, questions? All right, well, thank you all very much for coming, and feel free to take food on your way out, or stick around